Welcome to healthyourmath.com. Today we show you about the regression line, how it works. First of all, we have all the pairs, and to figure out their correlation, we need to use the correlation coefficient here. Based on the formula, we have n is the number of all the pairs here, sum of x times y, which we have the last column, sum of x, sum of y, which are the sum of data product together, divided by the other similar thing under the radical. So one thing is those two need to be positive. The top may be positive, may be negative. Then what we find out is fill out the table first. We have the data x and the data y here. We need to find the square of x, which the numbers here, 1 square, that is the square of x. 36 is the square of 6, and so on. 4 and 36. And the square of y here, we're taking the square of 15, 32, and so on. Right? 25 squared, 18, and 28. Right, the last one, we take the product of x and y. That is respectively 1 and 15 multiplied together. 6 and 32 is 192, and so on. Right, the last one is 168. Okay, so that is the table of xy. What we need is their sum. The sum of x, I have 19 here. The sum of the column y, 118, 93 for the x squared, 2,982, and the last column 511. Right, so that is the column actually we're using, the sum of x, sum of y, sum of x squared, sum of y squared, sum of xy. Right, respectively, those things are we put into the formula. Right, so how to put them in? I have the formula called R here. Well, first one, the n is 5 pairs. Sum of xy is the last column, 511. Sum of x is 19. Sum of y is 118. Well, the top number could be positive, could be negative. It doesn't matter. And the bottom, we have square root 5 times the sum of x squared, that's 93. The sum of x squared, to be pay attention, that's the square of sum of x, which taking is the 19 here. Right, and since that's under the square root, this number should and must be positive. Also similarly, I have n times sum of y squared minus the square of sum of y. Sum of y squared is 2,982 minus 118 squared. Also similarly should be positive. Well, when we do the calculation, the top one will give us 313. The bottom first radical will be 104. The second radical will be 986. Or you can multiply the radicals together, then take the square root, or take square root to each number, then take the product, doesn't matter. You could round it. Of course, the more decimal you keep, the more accurate you have, but 3 or 4 digits should be good enough. Right, and also the bottom should be a positive number. The top, not necessarily positive or negative, but also is the absolute of the top should be smaller than the bottom. Right, and of course, if anything like bottom is negative or top is greater than the bottom, we consider something was wrong here. Right, in here, at least we cannot say anything wrong here. Right, looks like okay. Then we have the division here, 3 digits decimal of r we could keep. That will give us 0.977. Right, that will be the result, and we can see that is kind of increasing correlation. Right, the r, as we mentioned before, the absolute value of the r should be less than or equal 1. right? So that is at least okay. All right, so let's move on to the second question. Right here is to find the equation of the regression line, which is the best fit line here. Right, as long as our R find in part A was very positive large number, right, then we can see that the regression line positive correlation exists anyway. Right? Then that makes it able to find the regression line. Right? Otherwise, if the R is more closer to 0, either positive or negative, we will lose its meaning to find the regression line. Arbitrary points, that's no pattern at all. We cannot find anything. Right? Here, looks like the pairs are strongly positive correlated, and of course the R showed us that such a huge number here, and of course intuitively that number is getting close to 1 or -1, shows a strong relationship. Right? So here, we're finding the slope and the y-intercept, right? Such that the line here is mx plus b, right? Just usual slope times the variable x plus the y-intercept, right? For the regression. And we had find those numbers in part A already. We have n times sigma x1 minus sum of x times sum of y, to be calculated as 313. And the bottom is in our regression correlation coefficient, that's the first radical underneath, right? That's this thing, which was 104. Right, so when we divide those things, we'll get 3.009, or if we want, just put 3 as the number, right? 3 or 3.0, doesn't matter. Then for the y-intercept here, that is the sum of y over n, which is 118 over 5. The slope we just find, that's 3, multiplied by 19 over 5. We'll get 12.2. Right, then at the end we can find the regression line, which y hat is 3x plus 12.2. Right, the next part of the question here, we just need to graph the regression line with just a basic idea of the line to graph. We need a slope and a point here. Pretty much we just need 2 points. Right? The first point is very clear, the y-intercept. And the second point, we can use any arbitrary input of x, which the easiest will be 1 input. Right, so the first point, we can use the y-intercept at 0, 12.2. Then we evaluate y hat at a 1 here. X equal 1 here, that's 3 times 1 plus 12.2. We get 15.2. Then the second point, we have that also. Right? Then we just use those 2 points to graph. Right, the scale just make sure that we cover everything. 1, 2, 3, 4, 5 up to 6 for the x and up to 32 for the y. Then for the point y-intercept here, we have 12.2, around between 10 and 15, a little bit down. Right, that's 12.2 here. And also at 1, that's above 15. Could put it on the left, 0, 12.2. And that's 1 that's a little bit above 15. Then just connect them together. And then we get the equation, we get the graph of this line.